Okay, good, you are back. So let's continue. We talked of course, types of nonlinearity. We have semi-linear, quasi-linear, and then you have the full nonlinear. And you can go through these definitions here. There is really nothing big here. A PDE is said to be fully nonlinear if they are okay. Go through all of these ones. You understand the second order nonlinearity. All of these ones are yours. Get your hands dirty and you go through all of these definitions. I'm not going to waste time with this because the good news, I'm dealing with the third years who know or who are comfortable with some of these things because they are already teaching them. Okay, mathematical problems. These are just some examples of the systems we are going to be looking at. And here we start simple. A mathematical PDE, there are two things. It can either be properly or well posed, or it can be ill posed. I think you must understand that. It can be either, it can be properly, what we are calling properly here, posed. This is the same as saying it is well posed. A mathematical PDE is said to be well posed if it satisfies the following. If it does not satisfy these ones, we say it is ill posed, meaning the inconsistency in that. And here, what are the three conditions it must satisfy? The first one is existence, there is uniqueness, and there is a continuity. These ones are not new. We have already discussed even these in calculus 1 and calculus 2. Existence theorem, uniqueness theorem, we did even in calculus 1, and we had a proof to this by contradiction. There are several uniqueness related theorems and proofs and lemmas. Continuity, you did, and the stability, you did dynamical systems. There is nothing. And when we say by continuity and stability, we are saying a smaller change in a given data produces a smaller change in the solution. These things Dr. Nakakawa handled these. And these ones, I'm sure you looked at phase spaces and you looked at directional fields. If it has been perturbed, you did what they call the perturbation theory here when you talk of a smaller change and a big change. Here, I am sure Dr. Nakakawa Juliet handled the perturbation theory, and in that you are trying to establish stability of that system. So continuity, stability, and in fact, this one you are discussing what we call the so-called continuous dynamical systems. So we are saying if any of these three is breached, then that problem is ill-posed. And I guess you've understood what that means. So it means that if we move along now, general second order. Okay, let's do some classification here, and under the categorization. Remember, I told you a PDE can be elliptic, parabolic, and hyperbolic. So we have a system there, and here you have to be mindful. If you have AUXX, this is second order. Okay, so this is second order, and you have a combination. This is second order, and then this one here is first order. So we are saying the classification, here we look at the conditions, which are more of a discriminants here. If b squared minus that is greater than 0, it is hyperbolic, this is parabolic, and then that one is elliptic. So if that is the case, then can we try to categorize some of these? Here you must be mindful that when we say UXX, this UXX here, remember it can as well be a UTT. Those I started with, we talked of the independent and the dependent. I give you an example. If you have a UXY, this is partial. I even added a T there, and I explained why I added T, that each process you do, T is involved. So the independent variables here, it is X and Y. Of course, T is always independent. The U is dependent. Is that okay? So though in this system here, we are using UXX, and when we say the A is for the coefficient of this UXX, it means when you use UTT, it can also be the same as UXX for this term here. Why? The logic is very simple. I have told you these are the independent variables. Why I'm explaining that? It's because in the first example here, we start with the UTT minus that. As always, because I'm disgusted by the Kuramas, the Kurama is going to come up here. He says this is UXX. If this is UXX, and here we are saying A, because remember when we say UXX, UYY, and here you have XX, and then you have UTT. Then the question is, why are we saying that A is C squared? You can see what we have here. If you want to rearrange this, so you have the Y, you see the YY here. That's why I said that UXX can be UTT and can be UYY. Reason, the reason is simple. What is the reason? They are all the dependent variables. So here, it takes on the first three, and this is the generic form. So a UYY, once the XX is there, then the XX goes with this one here, which is that part. That's why we are saying, according to this definition, if you look at the coefficient of A, if you look at the coefficient of A, rather the coefficient of UXX, which is A, UXX here is minus C squared, which is this one here. The first term, this one. Okay? But now when it comes to a B, of course, B here, if you look at B, B is the UXY. I think you remember I have already explained the meaning of this notation here. UXY does not appear in here, meaning the coefficient B, rather the coefficient B to UXY here would be 0, since this one does not appear. Now here you have CUYY, but here we have UTT. So instead of YY, you consider the UTT. I started by explaining this, that if you are looking at a PDE here, you have a U, and this is x, y, comma, t. These ones are all the x, y, t. The x, y, t, these variables here, these ones are all independent. It is the u here which is dependent. Remember, we started by looking at independent versus dependent. So any of these here, we have captured xx, yy. But since there is no yy and we have a tt there, then the tt replaces the uyy, the parameters. You always bog down my interest in managing some of the things. Okay, so that means that since you have a UTT, then that UTT is the so-called C equal to 1. And then we can do the necessary substitutions. On doing the necessary substitutions with respect to this, you realize that if you substitute these directly into this one here, you get a force squared, and of course for any value of C. Here, remember our C is positive, then it means that this so-called discriminant will always be greater than 0, and we are saying for it greater than 0, it is hyperbolic. Therefore, you deduce that this one is hyperbolic in nature. That one is finished. You can do these others. You can do this one and you do that one. Whatever says X comes first because I thought the PDE is in a variable T and X. Therefore, even if I take coefficient of UTT as okay, as it's okay, clarify. Since the time to exams is small, no other option apart from cramming. This is Molekwa. Human Molekwa Isaac, the best way to utter such contradicting statements would be, first of all, you own them and you say, if I revise your statement, you would say, in my opinion, my being you, in your opinion, comma, since the time, dash, dash, all right? Otherwise, when you are so obsessed with this opinion, then you know I am already smelling a retake from you. That cramming is going to bring you problems. And to answer this guy, what is the guy? Guys, there is another chat that was very easy to react to. This is Noareva. Noareva, there is no big issue here. Do as you suggest to see the conclusion you arrive at. Is that okay? So there is no big deal, Mr. Noareva. I agree with what you are saying. The question is, are the conclusions the same? That is key. Okay. Then we can go ahead. Now you can go through all of these examples here. Everything is here for you. Then there are more here. This is all your my third years, the finalists. You can do all of those ones. Good. We can now, these are more of techniques that are going to be used really to compute solutions to PDEs, because once you get exactly whatever, that is what I was trying to put forward, that I agree with you, just do it and see if the answer is the same. Okay. There is equation on condition, help pass through it. This is Arthur 1, ambitious. Since you are ambitious, you can talk to whatever Albert to answer this question that I have not understood. This is Arthur 1, ambitious. Okay, let's continue, guys. Engine space classification of these are just techniques. Somewhere along the way, linear algebra is going to come through, and we see how. So these techniques, we are going to preempt them in some of the solutions we are going to establish. Let's not take time on that. Hyperbolic system is said to be hyperbolic here now. Remember, we have already looked at the condition for hyperbolicity with respect to categorizing a PDE, and we said that will happen if the discriminant of this is greater than 0. But when you take an algebraic approach using that, then you can also argue this hyperbolicity of a given PDE, and you argue it based on the eigenvalues, and of course you look at the eigenvectors associated with each of this eigenvalue, and then we say if you have that space, how does this so-called PDE behave within that space? I repeat, for those I started with, I started by digging into the why, and I gave examples relating to spatial dynamics and cancer. And now when we talk of an eigenvector, and then rather eigenvalue, and then we get this so-called eigenvector, which is a field, and that field is more of a space, then you should surely comprehend now why linear algebra can easily come into getting solutions to these PDEs. Right, these are some systems, and the people doing physics, like the whatevers, these things, it is a cup of tea. I hope this command called ambitious, assuming the name is really a name, he's aware of something like this. Okay, wave equation, you have the advection equation, compressible, these Navier-Stokes equations. This one has wide applications. We also have the Kokaranga, which is used in mechanical engineering, and why it is used in mechanical engineering, it is a varying kind of stability, especially for motion kind of objects and perturbance of motion. So we have not exhausted this list, but that German guy who discovered the name is German in nature. Every time I mention it, people think I'm referring to someone from Southern Sudan. This man is saying in deriving Fourier, now look at this one. We consider whether the function is, but in the example, you did not consider, this one did not understand. It's semi-remo combined with your colleagues, and you go through these things. We have moved on. You better clarify this mess in the remaining 2 weeks. I think you did not understand what I discussed here. Given the nature of the question you are asking, when you say I did not consider that, is not even nor odd. If it is not even, or it is not, what are you saying? It is not even nor even. Maybe you say the even nor odd. If it does not cater for those, you use other approaches. There are very many approaches we discussed, Mr. Semirim. But when you are dealing with this, then the question is, what kind of range are you given? You see, you are asking this in total isolation of the range you are dealing with. You can have this when it is full range. When you are dealing with the full range, we don't give a damn whether it is even or odd. You need to revise your work properly, Mr. Brian Semirimu. If you are to ask this, then tag it to a range. Is that okay? Hopefully, I have answered that one. Okay, we continue. So, yes, this is basically it. Parabolic differential equations. These are demonstrations, elliptic and Laplacian. All of these are types of PDEs that these people in physics have already discussed. Okay. I don't want to get lost into this, but what you have here, this is trying to use the eigenvalue or that concept of linear algebra and getting the solutions to these PDEs. There is an example here. You just have to remember what you did in the PDEs. I can probably throw some highlights here. When you say consider a two-dimensional linearized compressible fluid flow equation of a thin body, this is what you have here. And then, of course, here, what you see here is simply trying to unpack what is in the system there, that you have your psi, which is the velocity, and of course, this velocity psi depends on x and y. Is that okay? So here you can easily know which one is independent and dependent, and it has this parameter here, which is m infinity, and we are saying this m infinity is derived from this, and this quotient is what is called the Mach number in a free stream, with the c infinity being the speed of sound, and you have the velocity, but we know that this will depend on x and y. So in this, we solve this, and in solving this, there is no big deal here. Since this is the case, we are saying, can we rewrite the system? How do you rewrite the system? These things you steal. This is still from what you did. This is, by the way, you can convert a PDE into an ODE, or you can break a second order into a first order. You remember in the DEs one, you did the systems of differential equations, and in that you do get a second order and you break it into second or third, you break it into systems of linear systems, and then you could also do it the other way around. This is the easy one. So we can apply that concept here in the PDEs. How does that come into play? We are saying if you have a system, writing a system of first order differential partial EDEs, PDE. So if you have this and you have this, then we are saying the other one becomes this. How does that become? Because we know that if you differentiate this one with respect to x, I think it is evidently clear here. If you let this be that and that, then it means ux, that is differentiating the left with respect to x partially. Then this one will simply give you phi xx. And here you have v. If you take vx, rather vy, you differentiate the left with respect to y. On the right, you'll get phi yy. Remember that what we are calling phi y. So here, what we are calling, just to get this. So what we have here is this EUX now, this whole thing here is now what you have here as that one. I hope we are together. So instead of having this as a second order, we are now going to write it as first order. Why? When you let U be phi x, then it means UX, which is now first order here, is equivalent to that one there. So we simply replace this one with that one there. This is now rescaling. So in the rescaling, of course, there are advantages. The computational cumbersomeness of a first order compared to a second order, of course, if it is second order, you scale it down to a first order, then the computational cumbersomeness is also significantly reduced. I hope we are clear there. All right. Okay. So in this case, if we go by that, what do we have? If we have this, then we can substitute it back. I've just demonstrated it in 4.15. And if you have done that, then here we go back here. So at first, if you differentiate with respect to x, then you differentiate with respect to y. So you have phi xy. Here, this is more of commutativity, that this is the same as that one there, this part here. So the order of the so-called independent variables, it does not really matter. Here it means you first of all differentiate with respect to y, and then you differentiate with respect to x. If it is here, you'll first of all differentiate with respect to x and then y, just like you did in integral calculus. Rather, is it calculus 3? Where you have, or vector calculus, where you have double integral, triple integrals, closed triple integrals. You keep throwing out one variable after the other once you differentiate, or rather once you integrate, and you keep the others fixed, and you keep eliminating them until you get the final solution. So in this case, remember, this is the system we have. We have split it into two now. So we have now two equations, and these are the equations we have. So the first one is this. This is one, which is ux plus vy. That comes from directly equation 4.15. But remember, in this, when we said that uy is qxx, and let me just, I think you remember. Apologies, guys. What happened is it's not a network issue. We don't have power. I'm currently in my office here in Makerere, and we don't have power. So not having power implies the servers off. I'm actually donating to you. You should even be praying for me to be more blessed with wealth, because it is my data coming to you for free to handle this lecture. I qualify to be called a patriot, or I am patriotic, if you so wish, because I am using my money and to buy data to lecture you. And what is so hurting is using my money to teach some of you who are Kuramas. That is very painful, spending data on Kurama. But for those who are not crammers, it is okay. And in this case, we can say you don't have to worry much. Why? It's because all is in order. So someone borrowed my phone. And in borrowing my phone, I really forgot that I was using it as a hotspot. So when the phone was borrowed, the signal for the hotspot was jeopardized. And that's why we had that network problem. Okay, so we can continue here, and in continuing, we will try to just a second, because I'm trying to make sure that my network doesn't get issues. I had used it as a hot spot, but okay. All right. So I think we are ready to continue. This money here, BT, we paid you, doctor. It's our tuition. Which tuition? Most of you, even the results have been held because you never paid this company who is swearing, selling. You paid me the tuition. What I know very many did. For me, I think the tuition you are paying goes to administrators. If I was being paid the tuition, then it means during Corona, because you are not studying, I wouldn't have got salary. Mr. BT, your tuition does not pay me. Your tuition is used to maintain those halls where you stay, fixed with the toilets. But the tuition does not pay me, my brother, my small brother, BT. And if I look here, I think BT is among those ones whose results are kept because you have not paid. But anyway, let's leave those ones, Mr. BT. If you have paid the tuition, good. But I know majority have not paid, and I don't know whether they will access the results. So those ones you will deal with the AR and the management. Okay, let's continue. What we are saying here is what we deal with. I was trying to mention before we lost the network that here we said the net. There you go. When we say if it is u which is equal to this, then we say ux subscript x, that would be phi xx, and then vy would be phi yy. So these are already, this one and this one can be combined. So that's why we are saying, if you look at the part we have now down here, those who are following, that if you look at these two, uy minus vx, that would give you a 0. Why? If you look at this and this, you have this, you have that. Why is that the case? Remember, you have this plus that, which is equal to a 0. So if you have this and that, which is equal to a 0, and we have already substituted this and this, then we can also take advantage of the other system, that is the ui. Is it the vy? Uy vx, that is if you commute. Because if you take this one here, if you look at this second equation here, I hope we are together, guys. If you look at this equation with respect to what we have up here, In the substitution, this was UI. But when you take this one to be U, this one was X, so we took it to be UX. Now, when you take it to be UI, if you take this one to be UI, then this one will be phi X, Y. I hope we are together. Then if you take this one to be X, this will be phi Y, X. Remember, initially we said the U is Kali phi, Kali X. Then we are saying U Y. What is this one? This means that this becomes Kali squared phi Kali X, Kali Y. Okay? Then this one is Vx. You said you are using this one. No. Sorry, guys, I was having a communication from Dr. Hassan Dumba. Sorry. Okay. So what I was saying is, the comments are very many. Doctor, your network is jumping. As I've told you, I'm using, actually why it is, I know, I agree with you, Sally Badru, that jumping. I think you are aware when you're using a network from a phone. This command Kisaka is saying techno problems. My friend, I'm not using the techno. My phone is called the Oppo. So I even don't know whether you have met that brand. It is purely Chinese and unique. It is called the Oppo, so it is not Techno. But the jumping you are talking of, Mr. Salibadiru, it's because I'm using it, and when calls come through, I think every time a call comes through, it disturbs the network. Yes, Malekwa, it is Chinese. Okay, so guys, what I am trying to say here is, since this is initially it was, I hope you are following, initially it was UX, that's why it was X. Now we